Hey, hello, what's up, guys? This is your yes sir with another video, and in this video, we're going to talk about pi bond. Okay, so we'll be doing a detailed discussion about pi bond. Okay, how it is formed, in what are the molecules it is present. We'll study everything. Okay, so let's start with the pi bond. So, pi bond is mainly formed by sideway or lateral or parallel overlap of atomic orbital. Okay, so how pi bond is being formed? It is formed by sideways, lateral, or parallel overlap of atomic orbital. Okay, let's have an example of this. Suppose this is the pi orbital. Okay, let's draw it. This is one of the pi orbital, plus this is the another pi orbital. Okay, it is having positive sign, same wave function, positive. Here it is negative, here it is negative. Both will undergo overlapping, and this is the overlapping zone. Okay, this is the overlapping zone, this is the internuclear axis. Okay, so whenever a pi bond is being formed along the internuclear axis, the electron density gets distributed above and below the internuclear axis. Let me draw the diagram. It's very simple, somewhat like this, and the electron density will be like this. Okay, so it's above and below the internuclear axis. This is the electron density. Okay, so let's see the example, and thus I'll take an example of oxygen. So if you look at the Lewis dot structure of oxygen, it is oxygen double bond oxygen. Okay, and oxygen is having 6 electrons in its outermost shell. So these are the 6 electrons, again the same. Okay, so there is one sigma bond and there is another pi bond. Okay, now pi bond is this one, sideways, lateral, or parallel overlap of atomic orbitals. So let's see. So here oxygen is having electronic configuration 1s2, 2s2, and it is 2p4, as the atomic number of oxygen is 8. Okay, so let's draw its orbital. So this is 1s2, this is 2s2, and this is 2p4. So let's make it. So here you can see there are total 2 unpaired electrons. Okay, and these unpaired electrons will undergo the overlapping, and these are the p orbitals. So we'll first draw the p orbital. Suppose this is the principal axis. Okay, so this is the one of the p orbital. Okay, and this is the other one. Okay, both are having electron. So let me show it like this. This is the electron. Okay, and this is the orbital of another oxygen atom. Okay, let's draw even this one. Yes, and both the orbitals are having electrons. So this is this one. It is having plus wave function, and this one is having a plus. It is minus, it is minus, plus, minus, plus, and this one is minus. Now these orbitals will undergo overlap. So you can see over here how will it take place. So it is the orbital of first oxygen atom, Okay, and this is the orbital of second oxygen atom, and this is the overlap zone having 2 electrons, and it leads to sigma bond. As we know that pi bond does not have its independent existence. This is the p orbital. Okay, you can call it as in py, and this one is in px. Now you'd be having doubt why not we are considering these two lone pair. Obviously these two lone pairs are there. You can see over here on each oxygen atom. These are the lone pairs. They do not participate in the bond formation. They can participate in bond formation only when the front atom is having vacant orbital. And since the front atom over here is oxygen, so there is no vacant orbital. Now these orbital are also having electron, unpaired electron, so they will also undergo overlap, and it will be somewhat like this. Okay, so they will undergo overlap like this. Yes, this is the overlap. It's above and below the plane. Okay, another example, you can also have nitrogen. Okay, just try by your own nitrogen. Okay, the electronic configuration of nitrogen is 1s2, 2s2, 2p3. So in nitrogen directly already there are 3 unpaired electrons. Okay, so this is 1, 2 and 3, and S is having a paired electron. So if you want, you can just draw the Lewis dot structure. It is and lone pair. So there will be 2 pi bonds. Okay, 2 pi bond. And here in case of oxygen, the pi bond is between 2p pi and 2p pi, because this is the limitation of Lewis dot structure. Okay, it got failed to explain the pi bond, the orbital which are forming the pi bond. So in nitrogen you will be forming 2 pi bonds and 1 sigma. Okay, so you just try it by your own. Now I'll move to the next, another type of sideways overlapping. The one which we have studied right now is a PP overlap. Okay, it is nothing but PP overlap. Okay, PP overlap, it is responsible for formation of pi bond. Let's move to the next one. We'll move towards PD overlap. Okay, so here we'll be talking about PD overlap. Okay, so this is PD overlap. So there will be one p orbital. Suppose this is the p orbital, plus there will be the d orbital. So let's have the example of d orbital. Suppose this is the d orbital. Let's take this orbital as in px. So this one will be pxy. See the overlap. So this is the internuclear axis, and obviously the sign remains same, plus. Okay, and then the overlap will be like this. This is p orbital, and this one is the D. So this is the overlap zone. Okay, this is the overlap zone, and it will lead to formation of p pi d pi bond. Okay, let's have an example of p pi d pi bond. Here I am having an example of SO3. As we know that here the central atom is sulfur. Sulfur is having atomic number 16, so its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p4. P orbital is having totally 4 electrons, and S is having 2 electrons. And we know that the Lewis dot structure of SO3 is somewhat like this. So there are total 6 bonds, and we know that for making 6 bonds we need to have 6 unpaired electrons. 6 unpaired electrons. Okay, so now we know that in order to get unpaired electron we need to have the excited state. This is called as ground state. Okay, this is called as ground state, and in order to excite this electron into the 3D, you might be knowing here it is 3 orbital. Okay, 1 2 3 4 5, which is vacant. Now there will be first excited state. Now for excited state, energy is required. Electron cannot jump without sufficient energy, and this energy is made available when oxygen atom approaches the central metal atom, that is sulfur. So one electron from here jumps to this one, and there is a paired one. But still there are only 4 unpaired electrons, so we'll proceed towards second excited state. Okay, so now we are having totally we are having totally 6 unpaired electrons. Okay, so these are totally 6 unpaired electrons. Let me draw a bit clear picture. So now this orbital will form a pi bond with this one, and this one will form with this, and here it will form this. Okay, so these are nothing but the pi bond. Okay, if you see this orbital, this is in 2p, and these two belongs to 3d. So now there is 3 sigma bond, and there is 3 pi bond. Okay, but the difference is what? Out of these 3 pi bond, 1 pi bond is, you can see here, it is the 2p orbital of oxygen, and it is the 2p orbital of sulfur. So it is 2p pi, 2p pi. Okay, and the other 2 pi bonds are in between. You can see here, it is this particular orbital, and this one is getting overlapped with 3d orbital of sulfur. So the other 2 pi bonds are 2p pi, 3d pi. Okay, so there are total 3 pi bonds. Okay, so this is all about the structure of sulfur trioxide. Next, move to the third type of overlap, which is nothing but like this, called as DD overlap. Okay, this is called as DD overlap. In this we'll be having 2 d orbital which will be overlapping among themselves. So this is one of the d orbital. Okay, and there will be another d orbital, which is this, and they're gonna overlap. So this is internuclear axis, and the overlapping will be somewhat like this. So let's draw both the d orbital. It is very rarely observed. It is observed very rarely observed, since 3d orbital is quite away from the nucleus. So the dd overlap is a very weak type of bond, very weak bond. Okay, so we have studied that there are generally 3 types of pi bond are formed, that is one by pp overlap, one is p pi d pi overlap, and the last one is d pi d pi overlap. Okay, so this is all about the type of p orbital, that is formation of pi orbital by sideways, lateral or parallel overlap. I hope you understood the video. Okay, don't forget to press the bell icon so that whenever I am making a video you'll get the notification. Okay, do share and subscribe. Thanks a lot for watching. Have a nice day.